Hello. I'm glad to have you all here. The next talk is by Armin Deliomini from Fantastic, and he talks about a year with OpenNebula as an alternative to commercial virtualization products. Have fun.
Thank you very much. Thanks for being here, guys, especially after having dinner. I'm going to do a test in the end, so you should really listen to what I'm saying. As already said, I'm Armin, and because I've been asked before, that's me on the picture with one of my future Ceph nodes. Yeah, I'm from a company called Fantastic. You probably have heard of us. We are doing like we're doing sports tracking for our users. Actually, the history started right the same as much as I know as OpenNebula started, 2009, and we have a heavy growth behind us and in front of us, hopefully. So, yeah, what are we doing exactly? We have like mobile apps for all major platforms and a web platform and some devices like this. Where you can do sports tracking, you know. So if you go out for a run or for a bike ride, you can track your run and upload the data to our services. You can have then statistics and show it to your friends. It's also like a social media platform for sports people, you know. So maybe some numbers in the beginning. Only to show with what kind of load are we dealing. We have around 100 million app downloads and around 50 million registered users on our web platform. That means, in average, and that's only our two main endpoints that are running in our OpenNebula environment, around 40,000 requests per minute on Java Enterprise from the mobiles and around 8,000 requests on the Ruby web platform, plus a whole bunch of backend services that process all the data that's uploaded to our platform. I would have shown you the overview, but the resolution is different, so it's the slide got a little bit mixed up, so I will skip that. Yeah, I started in 2013 in our company with one goal. We wanted to have a successor for our infrastructure that we had until then. Until then, we had like rented hardware at a very famous German web hoster. You know, all these root servers. I don't want to tell the name, but you can imagine probably. We had around 75 root servers, basically desktop machines, with all the issues that you can imagine with that, like stability, network outages, but we had surround sound, so that was cool. And we knew that with the growth that we were facing, that was not the infrastructure to go. So we sat together and defined a little bit what we wanted. Yeah, the first thing was we didn't want to have desktop hardware on our servers anymore. We wanted the network under our control, and we wanted to go for virtual application servers, because until then we had, you know, like 75 servers, and there was nearly no server running the same mix of applications. You know, everywhere you could find a little spot on resources, you would place a little application on that. And so we decided to have virtual application servers, and we needed a solution that was flexible enough for our growth and for the changing also focus of our company. You know, very young companies, they change direction a little bit, at least all the time, and so we needed flexibility on that as well, and scalability, sure. And we wanted it to be open source software, and surround sound was not really a must anymore. So, what did we look at? We started in beginning of 2013, with the knowledge that we didn't have a lot of time. I already posted a blog post on opennebula.com.org some time ago about that. It was more or less like we had some month before the whole system in Germany would not be handling the traffic anymore, you know. So we had some test setups and virtual setups in parallel, looking at different solutions. And I came from a company before that made customer solutions in the logistic business, and we used VMware, Oracle, and stuff like that, and big enterprise storages. So that was also the first thought to use VMware vSphere, because that would have been the classic choice somehow, you know. It would have been, we had a lot of experience on that. We knew that it would work with what we wanted to do. But there are the downsides. It's not open source. Everything else in our company nearly is open source, that all the software that we use. So we didn't want to get anything in that wasn't open source. And then there was the cost factor. Again, if you don't know exactly what your growth is going to be and what you need to run in your environment, then it's not a good thing if you know that everything is license in the end. Yeah. And there was no cloud bursting. That was also a factor for us, because we had, like, you can imagine if you have a mobile app and you do a big launch on iOS or Android, and there's a lot of people downloading that app and registering and logging into your infrastructure, that can be like a peak for a day or something. So you can size your infrastructure that it always would be able to handle that peaks, or you size it that it's able to handle the average or a little bit more and cover the peaks in an external infrastructure. So that was the way that we wanted to go. The other thing was we wanted Chef integration, because everything else in our company was rolled out by Chef. We are a Ruby company, that's why we use Chef instead of Puppet. So that was just because of the programming language for that. Yeah, and we would have needed Windows, and that was the big no for us. So that was VMware vSphere. We knew that it would work, but that was it. Then we looked at KVM. Simple KVM, you know, it would have been open source. We already used it for, you know, virtual machine manager on GNOME or whatever, and from bash management, this would work as well. But it would be like getting back to old days, more or less, in managing your infrastructure. And if you know now, we have around 300 virtual machines in our infrastructure, quite big ones. It would not be that nice if we would have to do it the old-fashioned way, yeah. And we wouldn't have any fancy features to tell our bosses. Yeah, then we looked at the classic OpenStack. It was state of the art. We actually had already decided on using OpenStack, and then we said, okay, before we started, we are going to Cebit and talk to the people of Ubuntu and OpenStack about how we should do that. Then we had some troubles with our flight and came there about noon. And we walked through that open source area and looked for people that could tell us anything about OpenStack, and there was nobody. And the only person that we met was Tino Vasquez, and he didn't tell us anything about OpenStack, but about OpenNebula. So OpenStack was another choice, but what was the real reason that we didn't take it and took OpenNebula instead? As I said before, I came from the virtualization world, the classic VMware vSphere. You have a single machine, it behaves like a physical machine somehow. And if you go then to Amazon Cloud or to OpenStack, that's totally different in thinking. You know, you have like machines, and if you, for me, it was nearly a shock to hear if I would shut down the machine, everything's gone. You know, when I heard that, then I knew, no, that's nothing for me. I want to go classic. You know, so why OpenNebula? There were some reasons. The first stuff was, it's totally painless for us. You know, we are 4 people in our operations team, and we have to deal with our internal infrastructure, our productive infrastructure, all the Linux machines that we are using, all the databases, and we have around 7 or 8 different database systems in our backend, beginning with Percona MySQL and Cassandra, MongoDB, Redis, Elasticsearch, whatever you can name some, we probably use it. That's nothing I'm proud of, actually, you know, but it's the way it is. So we needed something on the cloud infrastructure side that was painless for us, where we wouldn't need to focus all the time on, and that was OpenNebula for us. It works perfect with the classic proof technologies. What do you mean by that? We wanted to use NFS because we used it in VMware and it worked perfect. We wanted to use a classic DHCP server and not something like contextualization and stuff. And the good thing was we could, you know, we could decide on what we wanted to use. And as I said before as well, we only had time for some month, so and that's real true. In less than a week we set up our whole productive infrastructure for that. You know, we started with a quite small infrastructure, that's true, but it was set up in less than a week, and everything ran. And since then, I can tell you there's no big issues since then. And we have the strong community and support. That was also a big thing for us. Another thing was the flexibility. As I said before, we could use it as a classic virtual environment. You know, you have your virtual machines, you install software on that, you stop the machine, you start it again, you stop it, you start it again, it's here. No surprise, you know. But if you want, you can also think more cloudish. You know, if you start to get over your fears and start to think cloudish and start to use it more the way it's intended to be, you can also take out the positive aspects of it. So that was another thing. I will tell you a little bit more about that later. We could extend it with own logic. As I said before, we are a Ruby company. It was not that big thing to, you know, have that little hook or whatever running in your our infrastructure. We were able to use different hypervisors. We already made some tests with LXC instead of KVM, so we're using KVM with OpenNebula. And we already tested LXC and are probably going to use it parallel with KVM in future. And it was very easy to integrate it in our software automation. So we're using Chef, as I said before, and there was not that much cookbooks on the market, but it was very easy to write that ourselves. So that was another reason. And then the scalability. If we need more resources, we simply add nodes, you know, and the load peaks coverage in external clouds, that was another thing. We have a data center provider that has its own VMware-based cloud system, and it's in the same location, so we can burst in here and still have local network. And we could also burst into Amazon if we have like some asynchronous tasks. We did not use it that much now. We tested it a little bit, but not more than that. But we will probably use it in future, especially for our asynchronous web workers. Yeah, and we can use highly scalable storage backends. At the moment, our infrastructure is based on classic NetApp filer NFS storage backend, and that has somehow a limit in scaling. So that's also the good thing, that we can simply change that or add something else next to NFS. So how's our setup looking like? We actually have two OpenNebula instances. One is in our internal infrastructure. We use OpenNebula completely for every internal machine you can imagine, starting from development staging machines to Wiki and Git and whatever. You know, everything's running in OpenNebula cluster. And the good thing is we can use whatever hardware we can find for that. You know, we are a young company, no risk funded company that has millions of euros to spend in hardware. So our internal infrastructure is more or less like, oh, go to the next computer shop, buy something, put it in a case and start it. So that's perfect for OpenNebula. It simply works, you know. And then we have our productive cluster. We didn't do the self-built servers on that, but we use it for all the productive application servers and machines that you can imagine. The only thing that's not in the virtual environment is like the big database systems, because it wouldn't make too much sense to put the 32-node Cassandra cluster or the MongoDB cluster into the virtual environment at the moment. So, but everything else, everything that's about application logic is in our virtual environment. And even some database systems, the smaller ones, are running in there. So that's a picture from our data center. I don't want to show you the picture from the back side because the cables are a little bit messed, but let's pretend that it looks nice. We started with 8 Cisco KVM nodes, you know, like 16 cores with hyperthreading and 256 gigabyte of RAM. No local storage, only for the system. Maybe one thing that I have to mention is that everything in our environment is totally Ubuntu. We don't have any other distribution running or any other, like Windows or something. So that makes it a little bit easier for us, I have to say. That's also a reason why we're going to look at LXC in future, because if you have the same system everywhere, the same kernel everywhere, you don't have to, there's no real reason why not to look at it. So. Yeah, as I said before, we have 2 NetApp filers. They provide NFS to the KVM hosts. We have a 10G network, not because we outperform it, but simply for cabling simplicity. We don't use any contextualization at the moment, so at the moment our system, the virtual machine itself doesn't know that it's a virtual machine. It's like classic virtualization. We have around 250 to 300, I cannot say exactly, virtual machines running. And there are totally different loads, like databases, Ruby, Nginx, HA proxies, reverse proxies, whatever. Everything's running in the virtual environment. And most VMs at the moment are classic persistent images, so they have the persistent image run with the system on it and the application itself. What are we doing at the moment? At the moment, we extend our OpenNebula Cloud with the Blade Center because we found out that buying rack servers, we thought of buying a Blade Center in the beginning, but then we thought, no, we will never need more than 8 nodes, so that wouldn't make too much sense. Now, 30 nodes later, we know that it would have made sense, so we buy the Blade Center now. And what we need to do now is to look at something more scalable on the storage backend, because our NetApp filers, they are more or less on the limit soon, so we could add some more disk shelves and add some more euros and some more filers and some more controllers, but that would have a limit somewhere, you know. So that's why we look at Ceph at the moment. We had a very, very interesting test setup the last 2 weeks. The guys from Cisco and our hardware provider in Austria, they provided hardware for us and a test setup, and we already had a very positive test on Ceph. So that's just a question of time until we are going to implement it in the productive infrastructure as well. It was very promising to us, especially the stability. I can say you cannot bring the thing down. Yeah, another thing that we're working on, and that's maybe something that some of you can use. As I said before, we use Chef for our software automation, and at the moment we're cleaning up our OpenNebula cookbooks and get rid of the Runtastic specific code and split it a little bit up and publish the more generic parts of the cookbooks. So that could be useful for some of us. And another big thing at the moment is as I said before, we have a big database, MySQL database, Percona actually. And at the moment we have the problem then that we cannot scale it anymore, really. It's like, I don't know, 1 terabyte, 1.5 terabyte database and 756 gigabyte of RAM, and it's using it and everything. So we need to switch to something that's more scalable. That's why we are going to MongoDB. And we thought of, you know, using MongoDB on physical hardware like we did before. But we now, after 1.5 years using OpenNebula, we are very, we are used to have that clicky bunty interface, you know, where you simply can do your tasks and everything works, and you don't have to think about it. And we want to have that for the database as well. So that's why we are looking at LXC at the moment. We don't really wanna start it in KVM environment because it takes a lot of resources, especially from the disk backend. But the other thing is, if you put it on big hosts, MongoDB is a little bit tricky with that because the different instances would mess up your RAM and everything, and so you need something to fence the instances a little bit. That's why we look at LXC on OpenNebula for that. So that's our current projects we're working on. So you see it's 4 projects and 4 people. And there's some other stuff that we have to do. But that's all in the pipeline now. And then there are some future plans that we have with OpenNebula. First thing is we are probably going to add some nodes. Then, as I said before, use LXC additionally to KVM. Then we're going to add some nodes again. And then we wanna try thinking more cloudish. As I said before, we wanna try using the contextualization, especially for the network part, because we're using a typical ISC DHCP server that has all that MAC address reservations for the OpenNebula instances, works, but it's a single point. It's clustered and everything, but still it's a single point of failure somehow, you know, and it's not needed in OpenNebula. And we also want to use contextualization for network, but also for other parts. We can use it for connecting to a Chef server and stuff like that. And so that's another project. Maybe the next time that I'm here, I can tell you more about not being that much into virtualization anymore and more into cloud. Yeah, after that, we will probably add some more nodes to OpenNebula. And that's another big thing for us, and that's also one reason that we are using non-persistent machines more and more now, because we are on the way to prepare our whole environment to be able to use one flow, because you know, our load is is very different from day to day, and we can sometimes we cannot say why sometimes in Spain there is good weather, then people go out running, and we see that on our infrastructure. And sometimes there is bad weather, and there's nothing. Yeah, and you don't know before, So we want something that helps us to cope with all these situations without interference from one of us 4 guys all the time, So that's why we look at OneFlow. For scaling, especially the core parts of our infrastructure. It's like Java Enterprise servers and Ruby Nginx web servers for the backend. That's another big thing for us, especially in combination with the cloud bursting feature. Yeah. After that, we're going to add some nodes probably. So actually, I'm at the end of my presentation. I can say something just in general about OpenNebula. I'm really glad that we did that choice. That's nothing that the guys from OpenNebula told me to say. I really want to say that because when we started to think about the topic, we knew that it's going to be something that we have to, a very core part of our infrastructure, let's put it this way. And I can tell you, in the last 1.5 years, one big learning for us was, it simply works. You know that saying from that fruit guy, it simply works, like Apple, but it simply works. That's OpenNebula for us, because we simply do upgrades. There's no problem. We start our machines. If we don't have any resources, we add nodes. No issue on that, And that's really something that we are very keen of, because we can focus on the main parts of our infrastructure. And if you talk to me, I'm definitely no OpenNebula Pro, because I don't have to be. So that's the cool thing about OpenNebula, and that's the reason why we use it. Because if you have like a lot of technologies, then you don't want to focus on that one. Thank you. So if you have any questions, you can simply ask me. Oh ja. Jetzt gleich? Ah ja, okay. Passt.
So,
gut.
You have developed the drivers for LXC in OpenNebula, and you have plans for making it public.
Yeah, we actually there was not a lot to do on that. We simply had to change some basic driver code that was like, I don't know, it was like 50 minutes for us, because we were no Ruby devs, but I guess somebody that's more into Ruby would have done it in 5 or 10 minutes. But if we use it productive, then we will probably add some more code, and yeah, we can publish that as well, I guess. Yeah. But we already used it, so it works. We had our memcached instances running in LXC, because we had some memory issues with KVM on that. Yeah. Anything else? Okay. Yeah. Well, we didn't really have the need to use it, because the only thing that was necessary to use it for was more or less networking, because how to get the network configuration into the machine, and we solved that by simply simply reservating all the MAC addresses from the OpenNebula ranges in our DHCP server. And since we have like Chef for a software rollout, that's all done automatically for us. So if we add a new network, everything's done by Chef. And the other thing is, since we only use it for our, it's not a public cloud, it's our private cloud, and it's only more or less the 4 guys in our infrastructure that deploy machines on OpenNebula and that use it. We also don't have that SSH key stuff and everything, because also that is done by Chef for us. And we don't have like, we have one user, one admin, and we do everything with one admin because there's no need for anything else, you know. Only in our internal infrastructure we have some more users for the developers and stuff, but still it's a very small group, you know, that uses OpenNebula in our company. Yeah. Yeah. No, because it's like libvirt. So if you use KVM with that or LXC, there's no big difference on that, you know. So that was the very easy part. So as I said before, if we're going to use it productive and clean the driver up that we changed, we're probably going to publish it somewhere. So then anyone can use it. Yeah. Yeah, I mean Docker is based on LXC as much as I know. I never use Docker, but since we are the ops guys, we don't like Docker. Docker is not good for the ops. It's good for the devs, you know.
So you're going on record, so I'm putting that you don't like Docker.
Okay, yeah. I already had a talk about on that with some guys from MongoDB. Yeah, no, it's simply because we want to know what's going on in our container, you know. And with Docker, you don't really know it. You cannot change everything in there, and so for us, that's not the really cool thing. But we already thought about using Docker for our developers in the internal infrastructure, because for them it would be much more easy than at the moment. We have like 7 or 8 big staging machines, and if a dev needs to test some code, he reserves the machine and tests his code and then resets it to the snapshot before. That works, but it would be much more easy to use Docker for that, you know. But for the productive environment, I don't want to have it, so that's why I want to have LXC instead, you know. Yeah. Then I would say thank you.